So, welcome. In previous videos I have designed this little fellow, which is a MiniAMP I designed, and it's based on a CMOI op-amp. I already linked in the previous videos the original maker of it. It's a guy called Pao Chu Moi, and he made this op-amp circuit a really long time ago. It's been around for a long time. And I started this project because I needed it. I usually have two reasons of starting a project. One is pure curiosity, because I want to learn something, I want to experiment or just have fun. And the other reason is because I really need it. And this one is one I really needed. I work as an audio engineer, and I found that most older consoles, especially analog consoles, couldn't drive my headphones properly. So the headphones weren't loud enough to overcome the sound of the band on stage, and basically my headphones were useless. I have a pretty high impedance headphone. It's a Biodynamic DT770 Pro, and it has a 250 ohm impedance. So I started looking online for headphone amplifiers, and I found a few. Also a few portable, because that was important for me. But they were pretty expensive for what they are. They're like 20 euros and up. So I started researching some more, and I found the CMOI op-amp, the CMOI amplifier. And it is based on I don't know if I can get that in focus, but it's based on the OPA 2134 PA op-amp. It's a dual op-amp with a very, very low noise. So that's perfect for audio applications. So it started out on a breadboard, as it always does. It worked. I was quite happy with it, but there were a lot of loose connections, and the audio quality wasn't that great because of the loose connections. So I designed it on a perf board, which is this version. The chip's out because I reused the chip. This is not that expensive, but the chip's pretty expensive, and it worked as well. I've used this for a while, but because of the large solder traces and blobs and all exposed wiring, there was a bit of noise. So I thought, well, let's design that on a actual PCB. So I used Easy EDA for that, designed the schematic and made a PCB, and this is the version I came up with, which is all, as you can see, through-hole components. I should have used a dip socket for this, because as you can see I just soldered it in, so that's a bit of a waste of a chip. Maybe I can get that out. Anyway, it works on a 9-volt battery. I ordered some battery holder, or battery clips, battery holders, and it works fine as a switch in the pot meter with a little LED indicator light, and it works, but it's still a bit chunky. For my use, it's not really that chunky, but if you want to take it with you or put it in your pocket and drive your headphones, it's a pretty big thing. So I started with Smd Components, which is the version you saw me build earlier in other videos, which is a lot smaller. As you can see, it's I can get this in focus. It's less than half the size of the version 1, and this one works perfect as well. Same switch, same jacks, same LED. I didn't use surface mount electrolytics. I just because of the size, it doesn't really matter if you see it like this. It's just a few millimeters bigger than the pot meter, so I just left them through hole. And as any project, it starts with a schematic. It's basically the same design as CMOI, as the CMOI headphone amplifier, just a few different values of resistors and capacitors. So let me draw this design. That's why the whiteboard's here and not a cutting mat, the green one. So we start with a op-amp. I'll just do that over here, which is drawn as a triangle with all the leads. It's a bit difficult. I can't see. There's a microphone in front of my nose and a camera, so I have to improvise a bit with a positive and negative. It works on 9 volts, so this is plus 9 volts. That's minus 9 volts. And we have an input, which I'll draw over there. That's in. That goes through a potentiometer. And the wiper goes to the plus side of the op-amp through a capacitor and to the plus side. There's also a resistor over there. I'll draw it like this. That goes to ground. And that's basically the input side. Now we have the output side as well. I'll draw that over there. Is that still in? Yeah. There we go. That's out, which goes through a resistor, which is basically optional. I use it anyway just to eliminate most noise that can come from the op-amp. That's a 47R. I'll just mark them as I go along. This is a 10K pot meter, and the resistor is a 100K. I'll just draw that in. This is a 0.1 microfarad capacitor. Got that as well. Then we have the feedback loop, which is going from the output through a resistor to the negative side of the op-amp. This one, the feedback resistor, is a 10K, and there's another resistor here which goes to ground. Is that still? Yeah, that's still in the picture, and that's a 100K. This is basically the whole circuit. It's a very simple circuit, but it works very efficient. Again, based on the OPA 2134 PA, and just a little reminder, this is just one side of the op-amp. It's a dual op-amp, so we call this A. There's an exact duplicate of this circuit for the B side, and so then it's stereo. You have left and right. There also has to be a little power supply, which is pretty easy. I'll just move this over a bit and see if I can find an empty space to draw this on the whiteboard. Well, that's a bit difficult, but it will work. Which is basically a battery, and that's a 9-volt battery. You've got the negative side, the positive side, which I'll move it over a bit, which goes through a switch and then goes through a resistor, and there's an LED, and that goes to the negative side. Then there are 2 more resistors, and these resistors basically are creating a virtual ground. Another resistor there. So now we have our, there we go, virtual ground as well. We have 2 capacitors, one over there. I'll just draw it like this to make sure that, because these are electrolytics and they do have a polarity, unlike the ceramic capacitor. There we go. And this is our ground, and we got 9 volts over here, plus 9 volts, and we get minus 9 volts over there. Just some values. I used a 10K for this resistor. It doesn't have to be a really bright LED. It's just there, an indicator light that it is on and will drain your battery, so you don't forget to turn it off. These are both 4K7s, this one as well, and these are 220 microfarad capacitors. And that's basically it. I hope you enjoyed this video. If you want to know anything about this design, just leave a comment below. Don't forget to hit the subscribe or the like button, because that really helps. And I'll see you next time. Bye bye.